We are live now. Good day to all. Welcome you all to SSE E-Talk series conducted by Saveetha School of Engineering, Saveetha Institute of Medical and Technical Sciences. Today talk will be the 21st SSE E-Talk of the series. I am Dr. Deepak Arun, Associate Dean, International Affairs, School of Engineering, Saveetha Institute of Medical and Technical Sciences. At the outset, I extend my sincere thanks to our Honorable Chancellor, Sir. I also extend my sincere thanks to our Director, Madam, for Madam's continuous support, guidance, and motivation. I also extend my thanks to our Principal, Sir, and Vice Principal, Sir, for their motivation. Today we have with us Dr. Marc Holmes and Mr. Adam Jones. I can also see Dr. Salim with us. Thank you very much. Mr. Adam Jones is the Student Recruiter Manager. First, he will give a brief introduction about the university. Later, Dr. Marc Holmes will deliver a talk on the topic, how virtual reality is changing engineering design, saving a virtual fortune. Dr. Marc Holmes is currently the lead research officer of virtual reality in Department of Engineering at the University of Swansea. The Department of Engineering is researching virtual reality in response to the mainstream adoption of VR and interactive technologies. Dr. Marc is working on a wide range of projects surrounding the industrial applications and educational context of virtual reality. In his job, he leads research into engineering, medicine, education, and psychology. Marc has expertise in 3D modeling and simulation, software development, gamification, and serious games. I am very happy to welcome Dr. Holmes and also Mr. Adam to give their talk in our SSE E-Talk series conducted by Saveetha School of Engineering, Saveetha Institute of Medical and Technical Sciences. Over to you, Mr. Adam.
Thank you very much, Dr. Deepak, and thank you again to the Saveetha School of Engineering for inviting us and for the opportunity to speak to you all today. We'd hoped that we'd be in Chennai to deliver this in person, in class, and I sincerely hope that one day we will get to visit your fine institution. To tell you, first of all, a little bit about our institution, we are based in Swansea, which is on the south coast of Wales in the United Kingdom. It's a beautiful coastal city. We've got a population of only 250,000, so much smaller than Chennai, a lot quieter in the city centre than my familiarity with Chennai as well. And the university is the heart of our city. So the university, we are celebrating our centenary year this year. We were founded in 1920 when King George V laid our foundation stone. In that time, we've grown massively, not just in scale, but also in reputation. We are a dual campus university. So in the bottom image on your screen, that is our original Singleton Park campus, which is situated around the beach, just a small walk away from Swansea Bay. On the top there is our most recent campus, which opened only 5 years ago. And this is the home to our business school and our Faculty of Science and Engineering. We've got just under 20,000 students at Swansea University, of which around 30% are from overseas. Our engineering courses are all ranked in the top 15 in the UK, with research ranked 7th in the UK. And that top 15 ranking comes in the Times Good University Guide of 2020. What we're most proud of is our graduate level employability. We were founded by industry to serve industry. And so the graduates' careers is very important to us. 97% of our graduates are placed within 6 months of graduating, either in graduate level job or in further degree study. Within computer science specifically, we have graduates that go on and work in a variety of roles at a variety of companies, not just large multinationals like the likes of IBM, Google, Disney, Facebook, Microsoft, Sony, and others, but also more local UK companies. And for computer science, 93% of our graduates are placed within 6 months. For computer science, we're 8th in the UK overall in the Times and Sunday Times University Guide. We're 6th in the UK in computer science graduate prospects. fifth in the UK for student satisfaction in computer science, and fourth in the UK for student satisfaction in software engineering. Within our College of Engineering, we have 4 main research themes. This is what determines and influences the staff that we have working within the faculty, but also what programs we offer and what the content of those and application of those programs are. So we have research theme in digital and computational. There's one in health, well-being and sport, water and energy, and materials and manufacturing, all of which are incredibly multidisciplinary, working not just with engineers, but with faculty from other areas. Feeding into these research themes, we have our research centres, of which we have 6. And then amongst those 6 research centres, we have hundreds of research groups and projects. For this research work at Swansea University, we are ranked 10th overall in the UK. So for research impact, in the most recent assessment, which is the Research Excellence Framework of 2014, we were ranked 10th in the UK. For research power, we were ranked 10th in the UK. And for our research environment, we were ranked 2nd in the UK, beaten only by Cambridge University for the environment in which we do conduct this engineering research. And as I mentioned, we were founded by industry, and it's really, really important to us that on a variety of levels, whether that is research collaboration, staff sharing, industry-sponsored projects, student year in industry and internship placements, we work with these companies on screen, as well as many, many others. This is just a small snapshot of the scale of industry collaboration that we have in engineering at Swansea University. We have, again, a wide range of taught MSc programmes from traditional engineering disciplines such as civil engineering, structural, mechanical engineering or power engineering, through to some business and application related ones, such as engineering, leadership and management, sustainable engineering, management for international development. We've got computational focused degree programs, everything from computational mechanics all the way through to cybersecurity and data science. So again, it's a wide range of taught provision for postgraduate students at Swansea University. And what we're here to talk to you about today is one program in particular, and that's our MSc in virtual reality. 5 of our MSc programs are 2 years in duration, in which you can spend one of those years working in industry. So advanced computer science, computer modelling, electronic and electrical, materials and mechanical engineering can all be done with industry over 2 years. And as mentioned, we're going to talk about virtual reality today. So this is a brand new program where we can look at the science behind virtual reality, but also how we can apply that in the real world. It's multidisciplinary. We accept students from all backgrounds onto the program because we believe that this virtual reality concept can be applied in all different areas, whether it is in crime scene investigations, historical and archaeological digs, the training of emergency services, trying to solve pollution, plastic crisis in the world. So we're very excited now. I will hand over to Marc, who's going to talk to you today through this virtual reality area. Thank you very much, Dr. Deepak, and thank you, everyone.
Thank you, Ms. Over to you, Dr. Marc. You are the presenter now.
Thank you very much, Adam, and thank you very much, Dr. Deepak, and thank you for coming, all of you coming today to hear my talk. So I'm just going to share my screen now and start the talk. Hi. So today I'm going to talk to you guys about how VR is changing engineering design and how it's saving a virtual fortune. My name is Dr. Marc Holmes, and I am the Research Officer on Virtual Reality at the College of Engineering. A little bit about me and my research interests. As Dr. Deepak says, I'm interested in VR, computationally driven pedagoggy, gamification of tasks. That includes tasks which are not normally being gamified before in engineering. VR headset design is another research area I'm looking into quite heavily right now, because having done large-scale testing, we found there are issues with the headsets. So we're looking at changing their designs from an engineering standpoint. We do a lot on VR interactions to try and understand how people can interact with objects better and how they can end up being able to carry out tasks virtually in the way that they carry them out in the real life as well, and where the disconnect becomes so that they can actually carry that forward. And quite a lot recently has been empathy in VR, so psychology of VR, because you are dealing with humans and humans in VR. There's a lot of interactions with how people perceive the world and how it changes their emotions to their reactions. So whether they're understanding what it's like to be someone else, to how they feel about cutting down a virtual tree. This is how we can change people's behaviors by letting them experience new things through virtual reality. My prior research fields were discrete element method, which is lots of how rocks fall. And I used to do some work in additive layer manufacture as well, looking at how powders moved. So when I started doing work in virtual reality in 2016, these were the sort of demos we were seeing coming from the gaming industry. So people were immersed in the environment. They saw people were building worlds in the editors. People felt they were immersed and they were having fun and reacting to content coming at them, which made us feel that there was possibilities here for more educational and design purposes. Let's talk through a hype curve. So I don't know if you guys know what a hype curve is, so I'm just going to run through it again. So a hype curve is a kind of a perception of how technology is doing. So when technology comes along, it comes into existence and everyone thinks, okay, I'm not sure what it's going to be used for. And then after a while, it starts becoming, this technology can solve all of our problems. And unfortunately, that doesn't always work out. People start realizing, no, it's got limitations. It doesn't work outside the lab. It only works in these scenarios. I've misunderstood how it works, and people get disillusioned with the technology. That becomes a trough of disillusionment. And then there's what's called the slope of enlightenment, when people find use cases and it actually starts saving companies money and actually becomes a useful technology. So Garnier produces one of these each year for emerging technologies. In 2017, virtual reality was considered to be on the slope of enlightenment. It's considered to becoming a more valuable technology. Augmented reality is down here, and if I go to the next year, augmented reality is here, mixed reality here, but virtual reality is gone, because at this point, Garnier no longer considers VR to be a hype technology. And industry has been stating that as well. So we've got Capgemini, works with large range of heavy industries like automotive, steel manufacturers, and they went over and did a survey, and they found that companies who are doing large scale AR and VR implementations were making a 10% saving on their operational costs, which is huge. I mean, they're talking about millions to billions of pounds of money on operational costs a year, and 10% saving. That's a huge amount. So how was that achieved? So most of this was achieved through, I just realized this is going to be in the way. I need this. Sorry to move out. Sorry, apologies. It's my first time using WebEx, apologies. Can I do that? So if I just stop the screen share and share the, so I'll just talk over it. It's only just covering a small section of the slide. So this project design is why you're making the savings. The savings happen because when you're first designing a project, an engineering project, you come up with some definitions. They're basically words. They cost almost nothing to change. You've come up with some requirements. That's now you've said it needs to have X, Y, and Z. Okay, still doesn't take much to change. A couple of emails to change that. Conceptual designs. Okay, someone's come up with a drawing. It costs money. It's a day or two to make. Detailed design. An engineer spent like a week or so making a CAD design. Still can be fixed. Design building stage. At this point, there are objects in construction. At this point, you're talking about throwing away material, throwing away tooling. Testing. Okay, something's been built now. It's probably the time where you're going to make changes. It does mean having to go back and change all of those processes again. And then you've gone to live production. Your project is out there, and at that point, if you've got a problem with it, you're going to have to recall it, or you're going to have to change it in the next edition, which is damage to reputation of your company. That's a small fortune that could cost a company. So let's talk about Bell helicopters as an example. So Bell built this helicopter you see behind here, and they built this using VR. So normal routes for building a helicopter is they come up with an idea, they go away, create some definitions, they come up with some concept art. About 3 or 4 months later, they have a test cockpit built, and they get the test pilot to sit in it, and he says, I like this, I don't like this. And then they rip it apart and rebuild it. Now another month or two go past, he comes and sits in the next cockpit and then says, well, this needs to change, this needs to change. And it's quite a while before he actually gets towards actually having a prototype helicopter he can fly, even in a flight simulator or as a normal system, actual physical system. And it takes 5 or 7 years to actually get to the point where they actually have a helicopter. So what they did is now they moved VR into the process. So they came up with some concept ideas, quickly created some 3D models for them, got the flight engineer, the Unity developer, and the test pilot all in the same room, and he was flying a test model of the aircraft because they have these models they built now for how helicopters fly in general. So they put the parameters in, they put the overlay of what the helicopter will look in, and he's driving and flying. He says, okay, I don't like that panel. I've got bad visibility while trying to do this maneuver. The Unity developer turns features on and off, moves objects around. The flight engineer says, this will work, that won't work. All of a sudden, their workflow is seconds and days rather than weeks and months. And that's why they save so much time. So 6 months is a huge improvement. And it's not just them who's seeing that. So French National Space Centre were using VR in their CAD software process to reduce the project down by 25%. Safran nacelles, those are the engine modules you see on the edge of the aircraft. They saw a massive saving just even from a single VR system. A single VR system at the time would have cost about $5,000 for them. They found that they were reducing the time they were taking again, and the project was it was ahead of budget, and they were saving money because the mistakes were being avoided and changes were being made quicker, so they knew exactly what their customer wanted. NVIDIA, who make graphics cards, use it in a variety of different processes, from viewing the graphics card to seeing how the process is carried out as a whole. And they saw a reduction in saving. Lockheed Martin go in a different direction. They use it to see how people will interact with objects, and that saves them money in a variety of different ways by making changes there. SEAT, yet again, they are doing prototype reduction. So they are doing their prototypes, viewing them in VR and seeing, no, that needs to change. This panel's not in the right place. This seat doesn't look right. We're going to make that change now before they actually build the prototype. And building the prototypes answer questions, but by having those visual prototypes in VR first, they save a lot of money by not having to build a physical prototype for a visual inspection. So significant money reduction there. Ford went in a different direction. They've gone in virtual mannequins. They've been creating virtual representations of humans and seeing how they move around and interact with objects. And by seeing how they interact with objects, they can see when a human is going to hurt themselves by trying to lift up an object, and lower ergonomics. So when I've done some work with Tata, which is under NDA, but I can talk a little bit about it, which is, we did similar things with that. The design office was creating these big machines, and when they actually tried to have people access and install bits, they were getting back reports that this wasn't actually possible. And that happens quite a lot in CAD designs. You create a design which actually isn't possible to install. So they were using VR now to communicate those design purposes. So this is some general tools. So this is which we use quite commonly now, which is Iris VR and Gravity Sketch. So Iris VR is the top one here, where you see the little cabinets. This is used by Anglian Water and Iris VR. This is so Anglian Water and Alliance One. Alliance One do the drawings for Anglian Water, and Anglian Water is a water company. So on the site of Anglian Water, they have a VR headset, and so on the Alliance One. Alliance One show their new designs. So this is a box to store some of the measuring equipment for the water going through. The operator goes in and looks at this and has a look at it, and he says, well, actually, when I'm in VR, I can see that I'm going to bang my head, I'm going to hurt myself trying to operate this machine. This is going to be too small. So this machine was the installation around here would have cost 23,000. Ripping it out and changing it would have cost money. Instead, what happened was they just they drew where they wanted the design to be changed in VR, so they could explain to the designer what needs to be done. The box was made a slightly bit bigger, and more fortune was saved. Ford are doing similar things now by doing Gravity Sketch in their design, which we'll talk a bit more later. So one other use of VR is for sharing knowledge. So for this example here is from New Jersey. They have a New Jersey's waterboard system. They have a HoloLens system, and they've taken their maps. So rather than having to look at the maps and help people understand where the maps are, and just having to have somebody train up on the maps to learn how to read where the water mains and other stuff are, the HoloLens overlays the information using GPS and other known locations, overlays the known data they have on their water pipe system. So it's very clear to the engineer. They can see like under the ground and see where the pipes are. Okay, oops, apologies, I didn't mean to exit the presentation. Okay. Next thing is communication in VR. So at the moment we're using a video-based system, but there's also a lot of beneficiaries to using a VR-based communication system. So all I've been describing so far can be done in VR with communications now. So multiple people can load up a 3D model, stand around it, be able to draw and communicate over long distances. They can also interact with people from the 2D world. So they're trying to bring a mixture of people in, so it's not just exclusionary but beneficial to the company. And also some other benefits are spatial audio. So at the moment, you don't know if you guys notice quite often, but when we all talk, we end up all talking over each other. Whereas if we talk in VR, I can actually hear where one person is coming, where the other person is coming from. There's a differentiation in audio because of spatial audio. Okay, so communication is a bottleneck. So this is from Brooks Law, which is from software development, for Mythical Man Month, if you read the book, is adding human resources to a late software project makes it later. So the reason why this is ramp up time, communication overheads, and task divisibility. So ramp up time, you can have the best programmer in the world, but put him in front of a new program, he's going to have to look and see what's going on and where he needs to change what links to what, how this file structure is set up. It's going to take time to get them up to speed. Plus, you need to get them up to speed on the ideas you want to actually implement, which also takes time. So there's a big ramp up time, and this is not dissimilar in engineering. People can't come on an engineer can't come on the site and know exactly how an engineering process is going to be carried out or how an engineering design project is. There's the same sort of ramp up time there about bringing people up to speed. Communication overheads. So every time anyone tries to communicate with each other, there's an overhead. And when you're talking about a software project, especially or a design project, every person in that group needs to talk with each other, especially if they're sharing if they're sharing components, they have to talk to each other. They have to talk about what do you call the requirements of these components, whether that be software components or design engineering components. So there's a communication overhead, and that kind of communication overhead is kind of optimal up to about 10 people. 10 people on a project communicating is fine. From group theory, it kind of breaks down at 262, but you'll find long before that point you are actually unable to communicate with everyone in the organization properly. Task divisibility. Some tasks just can't be split up. A common example is 9 women can't birth a baby in 1 month. Some tasks have to be done by one person, and that happens quite often in design, even in coding actually, where there's just one task which has to be designed by one person because multiple people. You can do some things like pair programming, which give you a small boost, like 10 to 20%, and reduce errors, but they don't have the speed up of doubling. Okay, so let's talk about some of the equipment which is available. So in 1992, we actually had one of these. This is a cave autonomic virtual environment. What it is a series of 6 walls, and there's a series of 3D projectors which project an image. The lady there is wearing a pair of glasses and a controller, and that glasses and controller is tracked, and it knows where that is. So it then draws the 3D image on the walls in such a way that her perception of that engine is in full 3D. It's an expensive tech. It cost in the millions of pounds. So mainly it was automotive and aerospace who were doing stuff with this rather than other smaller companies. Older tech, but they're still out there. There's still people who use them. There's lots of great research done on these machines. The main issue, though, was there was very limited numbers of programs available for them due to the small market share. I think there was less than 1,000 of them built. So in 2016, the Oculus Rift and HTC Vive launched to consumer markets, and they reduced the cost down to thousands rather than millions. And they had large play space, which that's the area she can walk around in. That's what we refer to as a play space. And they had dual 6 degrees of freedom controllers, so they could interact with their environment, make changes, and do drawings and other stuff. And it was backed by game engines such as Unity and Unreal, and this made development rapid. As I was describing it to some people in task when we first started the project with them, they said that they consider Unity to be the front end of Visual Studio. So it became very easy and rapid for them to actually implement their ideas and have them available to interact with in a three-dimensional environment from a code base. So I'm going to talk about a research I did 2 years ago, which is step away from the CAD station, a hands-on and immersive approach to second year teaching of mechanical engineering design. So we wanted to see how engineers would react to being taught tools. And we were doing some case studies of individuals, but the problem was we were teaching a couple of people how to use VR, and we wanted to see how it would work on a large scale. So why not use our pre-existing resource, which is our students? So we were going to get them to all use a VR program and then be able to see how it changed their design process and how if it actually benefited or hindered their design process. So I did that with Dr. Pete Dorrington and Dr. Harrison. I also collaborated with Miss Brown and Miss Curtin as well on some of the psychology benefits. So why we chose engineering. Engineering is a subject with a wide range of core engineering skills, including design, materials, mechanics, fluid dynamics. They do a bit of computer modeling and manufacturing process and multi-physics. So they learn a wide range. So from coming up with the initial design to coming up with the detailed drawings to even further design layouts to doing the simulations on those parts to work out when they're going to fail and keep them going. So this is an example of the layouts we did. We combined in our theory a range of testing. So we didn't just do VR, we also did conceptual design. So we got them to do paper-based exercises describing it, and we also got them to do phone-based layouts. And the reason we did those both was because rather than saying, okay, well, you've compared VR to CAD, what about if they'd had done one of these other things? So we threw them all in there so we could see what the effect of all of them was. And it actually worked. I was worried that when we first talked about this, that this would reduce the power of the VR, but actually even with the phone-based modeling, well, you'll see. So there was 169 students involved in the study, groups in 6 of 33. Groups were designed to brief on what you call on concepts on VR and create a come up with a concept before they did VR and then do a detailed CAD profile and then they would do VR. I'm sorry, that's a duplication slide. The opportunity and why we were doing this is it addressed more open-ended design questions and problems. It increases the freedom of design. So as I talked about, they rather than being limited on what they can do in CAD, they should be able to consider new ideas and concepts in these tools and introduce new approaches and overcome the constraints they have gained in CAD. So, that's not particularly helpful. It came up. I'll answer questions at the end. So this is one of the things we normally say is that CAD is not design. CAD is a tool which enables design. Okay, so one of the things we were also thinking of our hypothesis was that it would change the perception of scale and spatial awareness. So we figured being in VR, you would actually have a much better sense of how the size of an object and how aware it was about where it was in its location. So we chose, we need to choose a tool. We need to choose a tool which was easy to use. So our tools that we were developing ourselves were decided to be too fiddly for 33 people trying to do interactions. So we looked for a commercial tool. We looked for an easy tool, intuitive, limited time to learn for the students. So it needs to be well designed in that regards. It needs instant interaction. We needed empathetic design. So users needed to understand by being immersed in the virtual society, immersive world, what they were designing and viewing the mechanical design. So it needs to have a slight connection to the CAD. So in the end, we went for a tool called Gravity Sketch, and Gravity Sketch provided us with a license. So Gravity Sketch lets you primarily draw in three-dimensional space these kind of lines which you see here. This guy's been just drawn some and he's just handling the object. You can also bring in three-dimensional parts like those wheels or engine blocks or other parts from CAD and be able to do work on them. When we first got this, they didn't have the access for they didn't have the support for multiplayer, but that's now changed. So you'll see a lot of comments about multiplayer, and that's now changed. Okay, so as I said, we introduced this after the concept generation phase, and they have done some design work. So they actually had a model to work from. We were setting up using Windows Mixed Reality Kits because they're nice and quick and easy to set up in place. So they were in groups of 6, one of them being in VR, the others being able to see on the screen what the person was doing, and they could discuss the concepts and the design. So this is an example of someone's workflow. So in the foam modeling, they came up with this kind of design for a human-powered taxi. That taxi was then brought into VR. They put some mannequins in so they could see how the people would fit. They could then make changes in designs and say, this doesn't work, this does work. That was then put into a proper design before coming up with a fully fledged design. The designs were significantly more intuitive, more creative than we'd had previously. People were trying lots of different ideas and designs, and the designs when they were completed fit humans in a way which before we were using VR, we were seeing quite designs weren't really thought very through. The spaces and the movements for the ergonomics hadn't been thought through so well. So these ones were good. So student feedback, particularly positive. They almost all enjoyed it. They found it was effective, and they were talking about it being effective on their design. So not only were we seeing a change in the design behavior from the prior years, they were noticing it as well. They found the sessions great at visualizing their things. They found that they could interact and draw. They found it a nice thing, but they kind of wished it was better. So this kind of actually feeds into where computer scientists will be able to help. So in the future, and where we talk with our virtual reality module about design on these things, we actually work with Gravity Sketch, so we're discussing some of these concepts with them. Is there are no dimensions. So the unit Gravity Sketch is all about free constraint design, so it doesn't really constrain you. So you're allowed to scale up and down. They've now added some features to lock the scale to 1-to-1, but it still doesn't have dimensions and stuff like that. So they had difficulty getting their scale right. So while they had good awareness of the ratios of objects, they weren't aware how big they were. So some objects have become hundreds of meters big, some have become meters small, and because of the way the program works, they had no sense of that scale. They wished for all members of the group could be in at the same time. So now Gravity Sketch has developed a multiplayer system so people can experience the same situation together. They wish they could put an environment around the taxi. They wanted to see their human-powered taxi. What would it look like on the street? What would it look like with customers around it, thinking about it going through the roads? And that also leads on to further more things about like interactions. Like, could they actually, like the helicopter design we talked earlier, could there be a model so that they could actually drive the taxi around and see how much weight they were adding and the design and see how that was affecting the ride and kind of pre-existing. So there's lots of interesting things which could be done to expand on what's been designed. So it doesn't have to be human-powered taxis, it could be cars, it could be any form of interaction of any product. Being able to test beforehand just makes it so much better. They also found one of the most frustrating things is, so this design tool was a kind of painting tool, but what it lacked was it wasn't like the traditional CAD tools. They couldn't come up with that design they were coming up with from before. They couldn't come up with those very nice detailed drawings for design shop telling them this part is going to be this far away and drawings. They couldn't do that, and they found they wanted to make changes to the SolidWorks model and then bring it back, but the moment the process is SolidWorks to OBJ to then into Gravity Sketch, there's no live link. So they would have loved there to be a live link where they could have had one person in SolidWorks making the normal changes in the normal workflow, and then another person making changes in Gravity Sketch. They would have liked, some of them would have liked preferred to have done the entire process in VR, being able to do the entire CAD process from start to finish, come up with their concepts, refinements, designs, come up with their drawings, and output a whole system in VR. And that doesn't exist. People haven't built it. So there's a great opportunity there for IT and computational scientists to come up with that. So summaries feedback. So students students viewed CAD, so that's the SolidWorks, as more of a barrier to creativity after the invention. They found that they were limited by the way that SolidWorks and other traditional programs work. Students' confidence in using VR to create, modify, and visualize were higher, and we saw that in the outputted work. The VR sessions improved the creativity in engineering modules, and the students enjoyed using VR. The students in the following years have actually asked to use the VR kits, so we now have because of COVID, we have a new cleaning procedure, and they're still having access now, so they can go do their design work for their third year projects and for their third year courses. They can now use Gravity Sketch to do their initial concept designs and the review work. So it has actually had a positive effect on the students, on their design work and their future careers. Okay, so as you guys are computer scientists and IT, there's a desire to have the entire process. So I mentioned Tata. So this is a picture of Tata Steel, which is just down the road from us. As Adam said, we were set up by industry, so we are not, unsurprisingly, not that far away from it. So this is Port Talbot. This is a sinter plant, and this is a blast furnace. I used to work on these when I used to be modelling how rocks fall. The Tata, we showed them this tool. They loved it. They started bringing designs in. Within 2 weeks, they had tried to bring their entire drawing set. That's everything you see which is metal in the scene. They wanted everything in there. They wanted the entire process. And that's millions and millions of objects, which is a real significant challenge, which both from a database handling side of view to IT management side of view to a kind of just straight down computational challenge of rendering all those objects, keeping them up to date, all the way down to the minute millimeter detail. So that became a significant challenge, trying to keep them restricted to dealing with one or two parts. And that would be one of the things we'll see eventually, in the same way that we see Google Earth, that people actually have a whole plant. And that will happen because of computer science and IT people like yourself learning and researching in this area, and virtual reality developers helping with the interactions. Shapes CAD. So CAD generates shapes by doing definitions about squares and circles and interactions and things, more complicated things like NURBS. There are other shapes which can be described, but shapes in CAD limit the design process. So there's work to be done in that field as well. The Gravity Sketch program defines everything as polygons, which is also limitations, because polygon is how computers draw things. They have a vertex, 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 and a edge, 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 and then a plane, and that's how they draw all objects. And that limits what's actually being designed to what's actually being things. So we had people complaining that their object wasn't smooth when it was actually being defined as a smooth shape. They were saying because of the way the graphics was being rendered, it was coming off as it wasn't. So lots of different work in how the rendering is done. Scanning prior resources. So there's lots of physical resources in the site, and also some of these designs, especially these conveyor belt chutes, get worn by the material. So the design they have isn't what's actually there. So they need to actually, they would like to have scans. So we try doing various scans and photogrammetry techniques, and photogrammetry techniques don't like things like reflections, and they don't like metallic surfaces quite often, and they don't like repeating surfaces. So there's a whole range of research and work to be done on changing that. And there's even using the pre-existing process, there's a lot of work which is done by computer scientists or photogrammetry experts or VR engineers to get that workflow into a program so they can use it. As I mentioned before, they'd love to test interactions. So when they're putting screws in, they want to see how that's going to be done. How when they're assembling the machine, they want to learn and see how that's done, that whole virtual mannequin. So that's another area which is done currently by it's done by hand. It's done by Unity developers designing the programs. It's not really been designed as a complete program, and most of the interactions are complicated because in VR you are kind of like a vengeful god. Your hand can pass through objects relatively easy. So how do you do that interaction? How do you do that interaction virtually? Do you have a haptic system, or is there some way that you can visually override? Because visual overriding does actually work. So there's a lot of testing and training and working at. Then continue that into training users to build and operate these machines, because if you can train and build someone to use these machines, that can save a lot of money. So these are blast furnaces and sinter plants. There's like one of them, and you can't have operators play with them. They have to learn how to use it, which means you have to have an operator sitting and watching the other operator, and that's a big tie up on the company. So if they lose that one operator, they are in trouble, so they have to have multiple operators. Training that other operator on how to use the machine can result in problems. It's one of the things where they really want to be able to train people up on machines without actually risking the machines. So they want to be able to operate them. And one of the things I talked about, empathy in VR, you can feel fear and social pressures in VR, which you can't experience on a 2D monitor. So there's some research I've read from research we've tried to implement on that about making people change their interactions with VR. So I hope we publish it next year, but there's others you can read from like Marco Giles and stuff where he's been doing research on GPs and making GPs cave to virtual patients and giving them antibiotics for diseases which don't work for antibiotics. And it's very interesting that we can get people to have those reactions in VR, and we can't get those reactions in a 2D monitor. And as I mentioned slightly throughout of this, and it comes through, all of this is about humans. All of VR is about humans. It's all about building for human senses, about building for the human eye and how it sees the focus, the high fidelity in the center, the outside, the human emotions and reactions, our ability to sense and interact with objects. We do quite a lot of work on human interaction because that's very important in VR. It's like, how do people understand what an object can do? How does the natural mapping help? And what matters and what doesn't matter? How much graphics do you need for people to understand an object in real world? So we do a lot of work on that too. As mentioned, we have this VR virtual reality MSc at Swansea. We also have an MA version as well. And we created it in partnership with industry because virtual reality developers are in rising demand, and they are actually COVID-19 proof. We've had lots and lots of people still hiring. Most of the COVID companies we've been working with have just switched to doing remote working, and they've actually benefited quite heavily. The degree is multidisciplinary, so we've included the College of Arts and Humanities to provide media theory and understanding on media marketing, and we also have a crossover with the School of Management for marketing, so you can understand how your product is going to market. With our degree, converts students from a variety of disciplines into this new thriving industry. So while a computer scientist will be able to bring the performance and power, and I'm sure you guys will, and the IT students also will learn and understand databases and other IT concepts very well, we find that having that cross-disciplinary effect is amazing. I'm actually just teaching a class right now, and we have people from arts, we have people from computer science backgrounds, we have people from engineering backgrounds, and they're communicating, and all their skill sets are merging together. They're actually providing new information to each other. One of the other things with our course is we provide a development kit. We know that if we leave students up to buy development kits, they end up with a variety of equipment. Sometimes it's very good, sometimes it's very bad. So we provided the perfect development kit, which will keep you guys being able to do all your courses, and you'll be able to keep it afterwards. Because as far as we're concerned, we think if you've been taught and trained up on something, you should be able to use it afterwards. And the best way to do that is to make sure you have the tools which you use to create it. This also has been very beneficial for us during COVID because it's mean that we now don't have any issues. The Zoom class I've just been teaching, we haven't been having to work out how to send out kits or arrange lab time for people who are having to isolate. We're teaching them all over the world. We also, when we do stuff with industry, a lot of the industry companies I was talking to were kind of hesitant because they said normally we end up having to send out a laptop to interns because they don't have the relevant equipment. We don't have to do that with us. We already have the equipment. So if you are interested, please send a message to us, and we will talk about. We can talk about possibly signing up to the course. So thank you very much. That has been my talk on how engineering is saving a virtual fortune.
Yeah, thank you, Dr. Mark. It was how virtual reality helps in engineering and other aspects. So let's open the forum for question and answer session. So if you participants, if you have any questions, you can open up now. Any general specific questions or general question, you want to learn, know more about VR, please open up and ask. Yeah. Okay, let's give them some time, and meanwhile I have a couple questions from some of our students. So one person, like, what is the VR in gaming? Like, how VR can help in gaming, and what is the future in gaming? That is one question I have.
Okay, so the question of VR gaming and what the future of VR gaming is. So I'll probably talk less from the research perspective here. I have done a little bit of research, and that's because we use gamification. So at the moment, VR in gaming is going through the same change which theatre did when it went from theatre did to movies. At the moment, we're trying to replicate VR games, 2D games, as they are as VR games. it's not the same environment. So doing the theatre in a movie doesn't really work the same way. The media theory changes, the way that we interact and we see the environment changes. So, for example, in VR, like when you talk about 360, people can look wherever they want to. They don't necessarily see what happens. So gaming has been changing. So there have been people making changes and breakthroughs. There have been successes like Beat Saber has done particularly well. There's also games like VR Sinners, and there's a variety of games coming through Half-Life Alexa, which have managed to make impacts and waves in the industry. Where things are going, it's about the difference in the storytelling. So when you tell a story in a 2D game, there's a tendency to take control, and your actions aren't actually made for you. Are made for you. You don't actually get the choices. Whereas in VR, you actually have a lot more freedom, and the world needs to react to you to immerse you and encapsulate you. So when it comes to storytelling, we will be seeing storytelling which is significantly more immersive. We will see storytelling which reacts a lot more to the way you behave, you interact, what you're looking, what you're doing, what you're saying. Because there are some tech demos on that already where the game reacts to what you're saying, and it's quite interesting how those games behave because they draw you in and are more immersive. So that's one way you'll see it. The other way you'll see it is a lot more about physical skill games. So things like Hollow Point or Half-Life Alexa or even Beat Saber are all skill games. They're about physical motion and movement. So they're really much more about you being able to move your body and hit points in time. It's not really about the skill-based reaction to be able to hit buttons in the right order. So I expect to see a lot more motion-based games which are try and push people's physical bodies. It's really interesting actually with Beat Saber. The game is about swinging lightsabers at blocks, and when they built the VR system for Steam VR's light system, they researched how fast a human hand could move, and they found that, increased the limit and put that as the engineering limit. Since people have been playing Beat Saber, they've actually broken that limit. So they've had to increase the performance of the headsets and the tracking systems to be able to cope with how fast people are now moving their wrists and their body parts to this music game. So it's quite interesting in that regards because it's actually resulted in new understandings of physical motion and human capabilities because of these games. So I'm not the best person to answer, but I hope that's given you some idea of what's going on in the industry.
Yeah, definitely. I also recently listened to a talk where architects, they're also working on virtual reality to build the old building, understand the present and the past. So that was also an interesting research was going on in the field of architecture. So let's move on to the participant line. Any questions? Okay. So if there is no more questions, I mean, thank you very much.
Deepak, Deepak, this is Chokalingam.
Please go ahead.
Yeah. Hear me? Deepak?
Please go ahead with your question. Yeah, I can very well hear you, sir. Please go ahead with your question. Yeah.
Professor, your session is very wonderful. Okay, we got a great points because already we are trying in VR and we are working, especially what Deepak quote architecture and other area. Especially we are working in the medical field related problem we are practicing because we are in computer science department. We are trying to find out some solutions with respect to the medical field because our university is also attached with the medical. And I have only one doubt: how VR can be helpful for in the like some general pathology related how VR is helping recent days.
So is that how VR is helping in general pathology?
Okay.
Is that the question? Sorry. So I've done some stuff with health. I'm primarily doing it for our sports and exercise health science group. So what we found is we've been using it to teach anatomy and other interactions. So they build a virtual skeleton, and that's particularly helped because they actually understand where the bones and the muscle groups are. I have been talking to our health science schools and some other people. So in medicine, of course, it's been used to for empathy purposes to help patients to help practitioners understand their patient's point of view, but also the other method I mentioned about empathy, where they're causing social pressure. So they're making practitioners, GP, general practitioners, understand how they're understanding what it feels like to be under pressure and strain. So they're pushing them with virtual characters who are belligerent and don't care what they have to say, and they're pushing them to give them something they want, and that's all something they'll experience in the industry, because that's one of the nice things about VR is we can put people in stressful situations and they have the stress responses, but they can actually train themselves to how to deal with those moments. Other aspects of where it's been used in medicine, I just was shown, I was sent a link yesterday to a HoloLens one where you actually wash your hands, which was to help visualize and check to see how people were washing their hands using a mixed reality headset to do with COVID-19 to make sure that hand washing was improved, which had shown signs of improvement. There's other applications about assembly, so when having to use various equipment like keyhole surgeries and stuff, there is a talk through lesson in VR where they have to assemble the components and build it, and then they see how well they do in real life, and they found compared to the other methods they were getting, this was from Imperial, they were doing particularly well about assembling very quickly, and they were making less errors. Another one was a haptic feedback surgery for a keyhole surgery system, so they were having interactions and haptic feedback to do a surgery virtually, and then they were watched to see how they actually did the surgery. And what was really interesting about that was compared to all the other methods they compared against, the VR method was actually so good that the doctor watching did not actually need to step in. He did not need to take over. He did not need to make corrections. The only suggestions at the end were minor statements about the practice. So it is big in the field of medicine. We also work with a group called Orchard, who are not far from us, and they work on distraction therapy. So patients in VR seeing environment which is disconnected to their environment, they are distracted while they're in pain, and that's helped reduce usage of painkillers such as opiums and other such painkillers which they want to reduce. They've been using VR instead to distract. Then most of this research comes from Snow Day, which was an app built for burn patients. So burn patients, of course, in significant agony, and when they're having their treatments done, even more significant agony, having to apply stuff to the surfaces of their skin. So Snow Day has them playing a virtual game on the headset where they are running through a field of ice with snowmen around throwing snowballs at people, and that mismatch in the sense of it, what you call, of the snow to their feeling changes the reaction, because visually your brain is saying it's cold, I'm seeing cold items, I should feel cold. And there's more research into that now. There's a group in, I forgot what they are, but they've just done a new piece of research where they've been vaporizing mint, and that's been helping triggering the trigeminal nerve, which makes you feel like it's cold as well. So there's more experiments into making people feel distraction, having a complete different sensory input to what they should be experiencing for patients, so that they end up feeling less pain or not in agony because they're distracted from their actual scenario, which makes doing procedures easier. I hope that gives a general view to answer your question.
Thank you. Thank you,
Yeah,
Professor. Given a great and wonderful explanation. Thank you.
Excellent.
Hello.
And I think one more professor in few questions. So please go ahead. Yeah, Professor.
Okay, sir, Hello, sir, is it audible?
Yeah, sir. Go ahead with your question. Go.
Yes,
Yeah,
we
yeah.
know.
Go. Please go ahead with your question. Yeah, please.
Yeah, sir, actually, we see there are a lot of virtual reality tools are available. So what is your idea about the 3D Max, Blender, and SketchUp? These are used for some animation drawings. So see, nowadays, 6 months, we are worrying about COVID. So what about COVID-19 related any gaming exercise, breathing exercise related VR tools? Is there anything to practice?
So, sorry, is your question about breathing tools, or did I misunderstand what you said? Drawing tools, was it?
Respect, if Mr. Saravanan allows me to brief the question, like it is asking about VR tools which
Yes.
can be used in this COVID-19 situation, like, yeah.
Okay, so you mentioned drawing tools, so there's things like 3D Max, Blender. Blender has been adding more virtual reality support. I mean, it also could be used to create the assets you would be using, but they are starting to add tools. Maya has significantly more support for VR. There's a tool which lets you do your full design work in VR. We mainly use a program called Unity, which is we use to actually create the VR interactions. So that lets us take our results, take the models from Blender or some other program like 3D Max, and then we can actually easily convert it and put in the interactions. And there's a lot of tools which have been developed in recent years and heavily now used during this COVID situation to actually share the environments. Another one which is freely and readily easily usable is Mozilla Hubs. It's limited on how much you can share, but it's useful for sharing three-dimensional environments. It provides a room like this, but it provides communication over distance.
Thank you, sir. Actually, see, the breathing exercise different from a different environment for cold places and some hot places. Is there any from your side? Do you have any link with for that?
What sort of, what do you call it? Sorry, apologies. Do you want to have a link of what we've of some stuff we've done, or
No, like some brief videos, like
breathing in and out?
scaling process.
Right. Sorry, I thought the word breathing, and now I understand. I think Oregon have something. Oregon VR. I haven't had to do much with the lungs, so my lungs are currently a static image. If you are looking for 3D models, we normally get them from the Japanese life science database, but I don't think they have a model of 3D breathing. If on SketchUp, there's probably a Sketchfab. There may actually be one. I remember discussing this with someone else. We used I'm trying to remember the name of the tool. We used a AR example. There was an AR t-shirt we used for a while, which actually had examples of breathing, but that's really more in person. I'm trying to think. There's probably some on SketchUp, but it's not something I've had to specifically deal with right now. So if Dr. Deepak gives me your email, I'll have a quick look for you afterwards and send you a link. There's probably something on Sketchfab which will meet your requirements. I remember seeing some hearts and other systems, so it wouldn't surprise me if there's a lung on there with the breathing exercises.
Thank you, Professor. Thank you. Bye.
Yeah. If possible, we will take one more question, one final question. Anybody want to ask question? Maybe
Sir,
one more
can I
question.
ask? Hello,
Yeah. Please introduce yourself and then ask the question. Yeah.
I'm Dr. Anita Shri from CSE department. Hello.
Hello?
Sir, can you hear me?
Yes, I can hear you.
Hello.
Yeah. Please go ahead, ma'am. Yeah, please go ahead.
Good evening, sir. Good evening, sir.
Good evening.
Sir, can you please explain the virtual inspection in the VM technology, specifically in the manufacturing process?
Okay, so the manufacturing process. So initially, as I stated, most design review is done is a review. So either a BIM model or a three-dimensional model of the parts is brought up, and that's used for inspection. When it comes to manufacturing, there is some work done by Chevrolet and others using the older Google Glass, where they would use the Google Glass to provide examples of the 3D model, and they would then ask the people in the manufacturing space to take images. There's also some work from Warwick on a virtual production line. So the production line is virtualized, and a event-based simulation. So how long does it take to go between one machine to the other is virtualized so that it can be seen how products are traveling down the line and how it's being assembled. So it has been used from all aspects of that. Scanning is being used quite heavily now, and then the requirement to then put that back into the virtual environment. So they scan the plant and they can then see how it's working. There's also just a thought about it. There's also works on the digital twins. So as you know, many manufacturing lines will have a set of computer systems next to them which will collect data about the plant, and that data can be sometimes hard to understand where that data is. So the things like a HoloLens can be used to naturally map that information over hardware and to allow operators to then see how the hardware has been changing over time. So say a temperature probe over a furnace over a period of time, or output of the speed of a belt, or whether a line would be pressurized. There were some when we talked with Tata, we talked about doing a lot of this stuff, and one of the main issues though is virtual reality is not a critical safe system. So they wanted to use Alexa, voice apps, or other things to activate the line and do more than just bring up information. They actually wanted to be able to know that a line was charged and be able to make sure that it was, so that when the operator started working on the machine, they would know that it was safe or not. The issue at the moment from engineering, from the research standpoint, is making virtual reality a critical safe system, because there's no way to know for sure that the virtual reality system is talking about exactly the right space, or talking exactly about the right if the data is live. So there's a research challenge there to overcome, but it has been researched as a concept, and they would love, people like Tata would love to be able to know exactly where all their employees are and what they currently are doing, and be able to see what they're changing and get a playback of what's been done, which is something we discussed as well.
Thank you very much, sir.
Yeah, thank you, ma'am. We can wind up. But
Yeah, I have
any
no
more
question, but
questions?
I wanted to
Okay,
say
Doctor,
thank
I
you.
think. Thank you
Yeah,
very
can
much,
I go
Dr.
ahead? Okay.
Salim. Yeah.
Yeah, I wanted to say thank you again to Dr. Mark from Swansea joining us today, and thank you to Dr. Deepak for arranging this. We hope that when COVID-19 goes away, we'll be able to visit or invite you to come and participate in some of potential collaborations and see this in action. So you're always welcome to visit us, or we can always, hopefully, if Mark is happy, we'll arrange for him to come and visit you in Chennai and maybe present live to an audience. We'll like to do that. So again, thank you very much. It was really good questions, and that was very informative. Thanks.
Yeah. We are definitely looking forward to signing in the coming week. And my special thanks to Mark for his wonderful presentation about virtual reality and its applications. And also I thank Mr. Adam, and a special thanks to Dr. Salim for his gracious presence today, and also for his introduction of Mr. Dr. Mark to us. So a very big thanks to all of you. Have a good day. Take care then. With this we'll end the session. Thank you all. I also thank the participants for joining. Thank you. Good day to all.
Thank you very much, all.
Yeah.